So we're diving deep into the world of natural language processing, specifically how machines got good at translating languages. We're talking about a pivotal moment back in 2017 with a paper simply titled, "Attention is All You Need." Catchy, right?
Definitely attention grabbing. And it really did change the game.
Okay, so before this attention thing took over, what was the state of the art? What were people using to tackle machine translation?
Well, back then it was all about RNNs.
RNNs, right? Recurrent neural networks.
Uh,
Like the workhorse of language AI.
exactly. But there was a problem, a pretty big one actually, when it came to handling longer sentences.
Okay, so what was the issue with RNNs? Were they just too slow?
Speed was a factor because they processed everything sequentially, word by word. But the bigger problem was forgetting. Imagine reading a mystery novel, and by the time you get to the who in it, you've completely forgotten the clues from the beginning.
Ouch. Makes sense. Like
Yeah.
information overload, RNN style.
Precisely. That's what was happening. These long-range dependencies in sentences, the connections between words that are far apart, RNNs just couldn't hold on to that information effectively.
So along comes this paper and bam, attention is all you need. Bold move.
Was the NLP community like, finally? Or more like, yeah, right, good luck with that?
I'd say there was a mix of excitement and skepticism. It was a pretty radical idea, tossing out those complex RNN structures entirely and just relying on this new attention mechanism. It was a gamble.
Okay, so let's break down this attention thing, because it's obviously the heart of the matter here. Sure. Think about how you're listening to me right now. You're not paying equal attention to every single word I say, are you?
Definitely not. Hopefully I'm filtering out the unimportant stuff.
Exactly. Your brain is naturally picking out what's relevant, what's important for understanding, and that, in essence, is attention. And this paper proposed a model, the transformer, which could do something similar with language.
So instead of getting bogged down by every single word, it's like the transformer can zoom in on the key parts of a sentence.
Yes. And the beauty of it is it can focus on those relationships between words regardless of how far apart they are in the sentence. No more forgetting those crucial details buried back in the text.
So it's like giving our machine translation models super reading comprehension skills then.
Exactly. And it's not just about remembering, it's about understanding the nuances, the way different parts of a sentence interact to create meaning.
Okay, so how does it do that? Is this where the multi-head thing comes in? I've heard that term thrown
You
around.
got it. This is where things get really interesting.
Hit me with it. What's multi-head attention all about?
Think about reading a good book. You're not just focused on the plot, right? You're also thinking about the characters, the writing style, maybe even making connections to other books you've read. Your brain is doing all these things at once.
Right, multiple layers of processing happening as I go.
And that's essentially what multi-head attention lets the transformer do. It can have one head focusing on how verbs relate to nouns, another one keeping track of the overall sentence structure all at the same time.
Like having a whole team of editors analyzing a text from different angles.
That's a great way to put it. And because it's processing all this information in parallel, it's also way faster than those old RNNs, especially when you're talking about long, complex sentences.
So if RNNs were like speed reading but missing the point, this is like deep, nuanced understanding and at lightning speed.
Precisely. And this speed boost wasn't just noticeable during the translation process itself. It also meant that training these models became much, much faster.
We're talking shaving off days, maybe even weeks from the training process.
You're not far off. The paper showed some pretty remarkable improvements in training time. And what's really cool is that they actually visualized how these different attention heads were learning. In the paper, there are these figures 2, 3, 4, and 5 that actually show how each head learned to focus on different aspects of the language.
So we're not just talking faster, we're talking smarter, more insightful.
Exactly. But this was just the beginning. One of the really amazing things about this paper was that it wasn't just a one-trick pony. They didn't just test it on translation. They also tried it on something called English constituency parsing.
Okay, and in plain English, that is.
It's a way to analyze the grammatical structure of a sentence, breaking it down into its core components, like noun phrases, verb phrases, and so on.
So kind of like a grammatical X-ray of a sentence.
I like that. And guess what? The transformer aced that too, which proved that its capabilities went way beyond simply swapping words between languages. This thing could understand the underlying structure of language itself.
Okay, now we're getting somewhere. So if I'm hearing you correctly, this wasn't just about making machine translation a bit better. This was a fundamental shift in how we could teach machines to understand and process language.
You got it.
So this all sounds pretty amazing. But why should we, the listeners, care about a bunch of attention-hogging transformers? What are the real-world implications of this?
That's the million-dollar question, and it's a big one. Well, let's just say the impact of this paper, it's been huge.
Huge how. Give me the rundown.
Okay, so imagine this. Everyone's trying to build a better horse-drawn carriage, right? Faster horses, fancier designs, the whole deal.
Okay, I'm with you.
Then, boom, someone rolls up in a working automobile.
Game over. Horse and buggy who?
Exactly. That's what this attention is all you need paper did for NLP. Total paradigm shift. And the applications, well, they're not just limited to translation anymore.
Which is already a mind-blowing feat in itself, let's be honest.
Totally. But we're talking chatbots that can actually hold a conversation, systems that can generate images from text descriptions, even real-time translation during video calls, all powered by transformers, all thanks to this one paper.
Okay, yeah, now that you mention it, those real-time translation tools are crazy impressive. I remember when that tech first came out, I was like, is this magic?
Right, it's like they cracked a code or something. And in a way, they did. They showed that this idea of attention, this thing our brains do naturally, could be harnessed to make machines understand language in a whole new way.
So it's like this paper is almost like a prophecy. They said attention is all you need, and it turns out they were totally right. Kind of poetic in a geeky NLP kind of way.
There's a certain elegance to it, isn't there? And here's the kicker. We're still just scratching the surface. The paper itself even says, hey, there's a lot more we can do with this, especially when it comes to making language generation less robotic, more like how humans actually talk and write.
So we're talking AI that doesn't just understand us, but can communicate like us. Write a novel, compose a symphony, that kind of thing.
It's not science fiction anymore. We're already seeing models that can generate different creative text formats like poems, code, scripts, musical pieces, you name it, all with this remarkably human-like quality.
Okay, now that's a bit scary, but also super cool. It makes you wonder, if we can replicate something as complex as human creativity in a machine, what else is possible?
Right. And that's the beauty of a discovery like this. It's not just about what we know now. It's about the possibilities it opens up for the future. Who knows what amazing applications we'll be talking about in another 5–10 years, all thanks to this one groundbreaking paper.
That's like we're standing at the edge of this huge, unexplored territory in AI. Kind of awe-inspiring when you think about it.
Totally. This paper, it's like it threw open the gauze to a whole new wing in the research facility, and suddenly we're seeing breakthroughs in fields we hadn't even thought to apply this concept to.
Mind-blowing. And to think, this paper came out in 2017. It's like yesterday in the tech world, and yet it's already had this monumental impact. Crazy, huh?
It really makes you think, doesn't it? This whole attention thing. It's like we take it for granted.
Because our brains, they just do it.
Exactly. But to actually build a model that can do that can filter and focus like that with language, with information, well, it's remarkable.
Totally. So where do we go from here? If attention can revolutionize how machines understand information, what other human skills could be next?
Now you're asking the really big questions. What if we could apply this to visual data or music? Maybe even human behavior itself. The possibilities, they're kind of endless.
Okay, now those are some seriously cool and maybe slightly terrifying thoughts. So for our listeners out there who, like us, are fascinated by this whole attention thing, what's a good next step for them? If they want to go deeper, I mean.
Well, reading the paper itself is a great start.
Even if it's a bit technical, right?
Yeah, even just skimming the abstract and the conclusion can give you a good sense of the impact. And from there, well, it's a rabbit hole. There are tons of articles and blog posts that break down the concepts in a more accessible way. Plus, the open source community has really embraced this, so there's a ton of code out there, tools and implementations you can actually play around with.
So it's not just a theory. People are actually using this stuff to build amazing things.
Oh, yeah. Big time. This paper wasn't just a breakthrough, it was like a starting gun. A whole new wave of AI research kicked off because of it.
That's incredible. Well, I'd say we've covered a lot of ground in this deep dive, from those early days of RNNs to this elegant attention solution. And now we're glimpsing the future of AI, and it's looking pretty wild. All thanks to this one powerful idea.
Couldn't have said it better myself.
So, to everyone listening, if you're as blown away by the power of attention as we are, let this be just the beginning of your journey. Dive into the paper, explore the applications, and who knows, maybe you'll be the one to discover the next big breakthrough in AI. Until next time.